complete the square, x squared minus x, and then factor the resulting perfect square trinomial. So to complete the square, what we want to do is add something to this such that I can rewrite it into a nice perfect squared thing that is something in the form x plus a number, quantity squared. If I'm able to do this, right, then this thing had to come from a polynomial that looks like this: x squared plus 2 times a times x plus a squared. Right? I just multiplied this out. So if I get to factor my polynomial so it looks like that, well, this is the polynomial it had to be so that it factored that way. All right. So completing the square is all about figuring out what it is I need to add to this x squared plus or minus some number of x's. In this case, minus x. What do I need to add to this so that I can then factor the resulting thing into this perfect square? All right. And that prospect sounds hard, but it's really not that hard if we make a couple of observances, and these are all observances that you can just jump right to if you remember this completing the square method. But if you don't remember it or haven't looked at it recently, let me remind you where it comes from. I want to figure out what a is. Well, a is sitting right there. It's not quite the whole coefficient in front of x. It's half of this coefficient. If I take whatever this number is, 2 times a, and divide it by 2, I'm left with just the a, right? And what I'm trying to come up with is what a is, and then I'll square it, and then I'll add it onto things. So I look at what I have, this x squared minus x. I realize that the coefficient in front of x is this -1 that's sitting right there. So what I'd like to do is take half of it so that I can figure out what that a is. So I'll take half of -1, and then I'm going to square it. Right. So this is the thing that I want to add to this so that I'm in that form. So let's do that. Let's add in -1/2 squared. Okay. Now I have exactly this form. I have something squared, and this term here is 2 times -1/2 times x. 2 times -1/2 is -1 times x is there. So this factors nicely. How does it factor? It factors like x plus a, x plus our a. So x plus our a is -1/2, so I incorporated that negative sign in there. If you wanted, you could write this instead of plus -1/2, you could write this as x minus 1/2, right? And that's why when I'm completing the square, even though I know that when I square this thing, I get the same thing as if I squared the non-negative version of it, I'm still going to include the negative sign when I'm writing this thing down, just so that when I do my factoring step, I don't have to do any thinking. I just look at exactly what's here, x. I look at exactly what's there, and I write it down. So if this is a -1/2, I write down my -1/2. If it had been a +1/2, that would be coming from something like a positive 1x, then I would have written down a positive 1/2. So here we are. This is, I guess, the answer that the question is looking for. Here's where we completed the square, and then here's where we factored the result into this perfect square trinomial here, x plus -1/2 quantity squared.